So, good morning everyone. My name is Juuso Koponen Jonatan Hildén. So, our short presentation focuses maybe on more about the motivation of our workshop than the actual contents, but we'll look slightly at that as well in the end. So, our background is in data visualization. We do data-driven work in different crises. So, we also do data analysis, but mostly we tend to put our work in visual format at the end. And these 15 minutes will mostly be spent explaining why visual simplification works so well for many different types of data. We run a small design studio in Helsinki called Hildén. We do mostly government work, also some companies and media, but our biggest sector of clients is in the public sector. Here's an example of a 3D visualization we did for the mayor of Helsinki. And we are also authors, so we've written the first Finnish language book on data visualization called Data Näkyväksi. It's currently being translated to English. The working title is Data Visualization Handbook in English, and hopefully that will be out early next year. As Google's chief economist, Hal Varian, wrote in McKinsey Quarterly a couple years back, the main tension maybe in our field is that we now have essentially free and ubiquitous data, and the scarce factor is really to be able to extract value and meaning from that data. How do we make data more accessible? The answer has been known for more than 200 years ago, when the Scottish economist and adventurer William Playfair wrote that a visual representation of data gives a simple, accurate, and permanent idea by giving a form and shape to a number of separate ideas, which otherwise would remain abstract and unconnected. He was the inventor of some very typical charts that you've all seen and probably used in your work. He invented the bar chart, line chart, and the pie chart, which still after 200 years are the most common ways of visualizing data, in addition to maps and some other very classic ways for doing that. So, what makes these visual representations so powerful? Let's look at a typical example of a data set. So this is part of a table that lists which party won in each of the municipalities in Finland in a local election that was held this spring. And it's great for finding the result of a single municipality. So if you want to know what was the biggest party in, let's say, Espoo, which is a suburb of Helsinki, you can check that it's the KOK, which means Kokoomus, the National Coalition Party. So for checking the individual result there, that works really nicely. But it's really hard to make an overall picture just looking at a table like this. So, for example, if there are regional patterns or something like that, it doesn't really come up from the list. So this corporate map, created by the national broadcaster, Yle, is more illuminating, and now we can start to see some patterns here. The center party, which is agrarian party and which is popular in less populated parts of the country, it can be seen that they won the largest number of municipalities, so most of the map is green, which is their symbolic color. And it's really easy to see that the Swedish People's Party, whose color is yellow, performed well in the Swedish-speaking regions, in the Ostrobothnia and along the southern coast. And there are some other interesting patterns here, but nevertheless, this pattern or map has its own problems as well. For example, most of Finnish people actually live south of this line, so our population is heavily concentrated in southern parts of the country. And for that reason, a map like this doesn't explain in the best possible way who really won the most votes in this election. So for this reason, we created this visualization for Aamulehti, which is a regional newspaper published in Tampere. And here we created, instead of a traditional map, a cartogram. So the point of a cartogram is that instead of using the geographically accurate shapes for the municipalities, the hexagons here representing the municipalities are scaled according to the number of eligible voters. So now it's easier to see that although the center party was the winner in the largest number of individual municipalities, most of those municipalities are quite small by population. So actually the National Coalition, the Conservative Party, and then the Social Democrats, they perform much better in the larger municipalities in southern parts of Finland. Of course, this display that only shows the largest party in each of the municipalities also hides some of the variation in the actual result. For example, the populist, the Finns party, is not shown on the map, although they received twice the amount of votes compared to the Swedish People's Party. But the thing is that their voters are not so concentrated into certain municipalities, but they have the support all around the country, and they weren't the biggest party in any municipality, but they still received a sizable amount of votes. Thankfully, this is an interactive visualization which enables you to drill down on the details, so some of that data that might have been missed in a single picture can be brought up by interacting with it and showing, getting different views of the data. So this is a typical example of data visualization in that it lets you drill down in the details of the data.
So what makes visualization so uniquely powerful in both communication and analysis? This picture can give some part of the answer. To put it shortly, we have a very extensive specialization in treating visual material in our brains. This is a 1989 study, and according to this, sight transmits roughly 10 times the amount of information from the outside world to the central nervous system compared to most other. To the next most powerful sense, touch, and we have a quarter of our brain, our cerebral cortex, dedicated to just processing visual information unconsciously. This is more than anything else. It's more than what we have for sort of conscious thinking in our brains. So we are heavily specialized on using visual information, and it's the main way that we gain knowledge about the world around us. So for this reason, it's a very powerful thing to utilize, as long as we do it efficiently. But it doesn't mean that turning data into pictures magically increases understanding. This visualization purports to show 500,000 tweets coded by language, maybe so, or then it's just a nice 80s clothing pattern or random doodles or whatever. It's really impossible to know because there's so much data crammed into it that we cannot untangle it at all. We cannot process it visually and censor it. It's always possible to put data in an image, but and have a logic for how this happens, but it doesn't mean that anyone can get it back out of there again. So we don't want to make numbers interesting, but as Albert de Cairo says, the goal of a graphic is not to make them interesting, but to transform the numbers or other phenomena into visual shapes from which the human brain can extract meaning. So we have to take into account the very real limitations of our eyes and brains and build presentations that support these capabilities. Otherwise, the power of visual display is more or less lost. This example that some of you probably have seen, created by Marko Plahuta and alias Vintis. Did I get that even approximately right? I'm not sure. For DEVNIC, and it's a map of Ljubljana showing numbers and kinds of cars towed away for parking violations in different parts of the city. By simplifying, by leaving out unnecessary details that are not required in this case for understanding what's being presented, the map enables us to make visual comparisons of patterns and gain insights about what's going on here. So this is no wonder that this map won the Best Map Award in the prestigious Malofie News Graphics competition last year, and well, that's the most important competition for use of information graphics in the world. So it's very accomplished work. What's abstracted away here is obviously buildings, parks, all this kind of thing. So there's just the outline road network and then the data visualization in yellow, which kind of emphasizes the roads where these violations are happening. Statistician John Tukey, who pioneered many data visualization techniques in the 70s, has put it succinctly that the greatest value of a picture is when it forces us to notice what we never expected to see. So visualizing is not mainly about confirming expectations, but the biggest power comes when we use visualizations to actually gain insights that were hidden in data tables or summary statistics that wouldn't show these things. So putting data into visual form gives us a possibility of finding out some really unexpected stuff we do it right.
A case in point is simple visualization of election results from Denmark from 2014. So on that year, when European elections were held, at the same time there was a referendum on whether Denmark should join the so-called European Unitary Patent Court. So it's quite a wonkish topic, but it illustrates our point nicely. So this is a scatter plot, and what's been plotted here this was originally made by Open Doors Denmark, which is a local NGO there, but we've redrawn it here for clarity. So each of these points in this visualization is a voting precinct. So there are something like 2,000 voting precincts in Denmark. And what's plotted here is the support for the two parties that opposed the court. And so they advocated a no vote in the referendum, and then the number of no votes. And what you can see is probably what you would expect. Where these two parties gained a lot of votes, there were also a lot of no votes in the referendum. So the point cloud is sort of quite tight, which implies a strong correlation. But then on the top left there is a point that sort of really stands out. You know, you don't have to look very long for the visualization to notice that there's something amiss. So what's different about this particular voting precinct, which is so different from anything else? It really stands out there. Well, it turns out that this precinct, called Torbäck, actually made the mistake of reporting the yes and no votes in the referendum the wrong way around to the central voting board, which is quite a serious mistake when you think about it. Like, you had one job and you blew it. The thing is that this sort of mistake can happen when you just work with the numbers in a table. But the minute you put it in a visual form, you cannot not see that. It just, you know, pops out from there. And this goes to show that visualizations are really powerful in sort of recognizing patterns and outliers from those patterns.
During the next 2 days, we'll try to look at various data sets and see how they can inform tourist-related decisions in Ljubljana. We have classic statistics and surveys, but we also have some more unorthodox data, such as geocoded Flickr images, from which you can see a small sample here. The hypothesis is that photos taken by tourists will tell us what they find interesting and memorable in Ljubljana. Also, incidentally, told us that people upload really random stuff on Flickr and put it public. But I think we'll have something interesting coming out of this, and there's always the possibility of doing additional analysis on the actual pictures to see like what time of day or whatever have been taken. We just put them on the map, and that already reveals something about Ljubljana's tourism hotspots. But this is just the starting point, of course. So here's a bunch. The red dots are the same Flickr images. There's 250 of them from a certain time period. There's thousands and thousands of them, so we can download more as needed. And you can see that there are very clear clusters and huge areas without any pictures, which is not so surprising.
We also have similar data for Instagram, and the good thing about Instagram is that people also write about the photos, so you have hashtags and other writings about them. So here are some of the most popular words used to describe photos from Ljubljana: street art, love, architecture, Eurobasket 2017, clearly, congratulations, metalkova, and so on. And this is already quite interesting, but let's see where this will lead us when we dig further down to it. And to finish off this presentation, we also have the most used emojis. So these are the most commonly used emojis to describe photos which are tagged either Ljubljana or Visit Ljubljana. So the heart emoji was by far the most popular, but what's interesting, the second most popular is the rain emoji there with the umbrella, and then coffee on the third place. So let's see where this will take us. Here's the download link in case you want to check out some of the links in some of the slides. So there's a PDF version of that, and I guess you might be able to get that anyway afterwards by the organizer. Thank you.